Welcome to ETL 512, Electronic Circuit Analysis. Chapter 1, Introduction to Electronic Circuit. Part 3, Diode Rectifier. This chapter focuses on diode configurations, series and parallel and voltage multipliers. We'll also go through half-wave and full-wave rectifiers. What is a diode rectifier? A diode rectifier is a circuit that converts alternating current, AC, into direct current, DC. Diodes act like one-way valves, only allowing current to pass in one direction. This function is essential in converting AC to usable DC power. There are two main types of uncontrolled diode rectifiers we'll discuss: half-wave rectifiers, full-wave rectifiers. Both are studied under two load conditions, R load and RL load. Let's now focus on the half-wave rectifier. It converts AC to DC by allowing only one half of the input signal, either positive or negative, to pass through. This is a half-wave rectifier using a resistor as the load. During the positive half cycle, the diode is forward biased, so current flows and voltage appears across the resistor. During the negative half cycle, the diode is reverse biased, acting like an open switch, so the output is zero. In short, the diode only passes the positive half of the AC signal. The average DC output voltage is about 0.318 times the peak voltage, written as VDC equals 0.318 Vm. When using a silicon diode, we must take into account the threshold voltage, which is approximately 0.7 volts. The diode only starts conducting when the input voltage exceeds this value. Therefore, the average output voltage becomes approximately 0.31 times the difference between the peak voltage and the diode threshold voltage of 0.7 volts. When we add an inductor in series with the resistor, an RL load, the output changes. The inductor resists sudden changes in current, so the current continues to flow even after the input voltage drops. This results in a more continuous waveform compared to the R load. Here, we see the output voltage and current waveforms for the RL load. The current waveform does not return to zero immediately after each cycle because the inductor releases stored energy, creating a smoother output. To further stabilize the current in an RL circuit, a freewheeling diode, labeled DF, can be connected across the load. The main diode conducts during the positive cycle, and the freewheeling diode conducts during the negative cycle. This allows current to continue circulating through the inductor even when the input voltage is zero or negative. Now, we move on to the full-wave rectifier. Unlike the half-wave rectifier, this rectifier allows both the positive and negative halves of the AC signal to pass, converting them into a unidirectional output. There are two main types of full-wave rectifiers. The center-tap transformer configuration uses two diodes. The bridge rectifier configuration uses four diodes. Both convert the full AC waveform into DC, but the bridge configuration is more compact and widely used. Bridge rectifiers are commonly available as ready-to-use modules. They consist of four diodes inside a single plastic-encased unit with four pins, two for AC input and two for DC output. During the positive half of the AC input, two diodes conduct current through the load in one direction. During the negative half of the input cycle, the other two diodes conduct, continuing to direct current through the load in the same direction. This ensures that current always flows in one direction across the load, providing us with full-wave rectification. This slide shows the output waveform of a full-wave rectifier with a resistive load. We can observe that the output voltage and current are both unidirectional and exhibit two pulses per input cycle, resulting in a smoother output. Now let's look at the key calculations for a full-wave rectifier. The average output voltage is approximately 0.637 times the peak input voltage. The average current is equal to this voltage divided by the resistance. If we use a bridge rectifier with silicon diodes, each with a drop of 0.7 volts, then the total voltage drop is 1.4 volts. Therefore, the average output voltage becomes approximately 0.636 times the difference between the peak voltage and 1.4 volts. To summarize, the full-wave rectifier produces an average DC output that is twice as much as the half-wave rectifier. However, the peak inverse voltage, or PIV, across each diode is equal to 2 times the peak input voltage. Thank you, and see you in the next video.